Hello everyone. So today I'm with one more very good problem on arrays, data structures and algorithm series. I think this is very easy problem wherein we are trying to find out between two strings if they are anagram or not. So I just want to explain what is anagram. An anagram is a word or phrase formed by rearranging the letters of another. So using all the original letters exactly once. For example, let's say we have two words here, ANAGRAM and NAGARAM. These are two anagrams as both contains the same letter with the same frequencies. So that is pretty much all in terms of valid anagram. What exactly it means by valid anagram. So if it breaks this particular rule, if two strings break this particular rule, that is not a valid paragraph. So we have to, always, as I said, come to a solution. Brute force is the first approach that you can always share with any person who is asking, any interviewer who is asking, but do not try to go for the code or implementation. Just take 1 or 2 minutes of time explaining the brute force solution and then directly jump into the optimized solution for any particular problem. We will follow the same approach here. So before that, let me quickly do some Java code, and then we will do the Java code here in IntelliJ, and then we will publish this Java code into Leetcode, so that we can check if solution is good or not. So yeah, so let me go create something here. So I'll be creating one class which is valid anagram, valid anagram, and I will put this class level comment. As usual, I usually follow this practice so that we do not have to come again and again here to find out. Yeah, so this is pretty much all. Now let me give the structure of my Java code. Like, we will have first input, then we have our logic, and then we have our result. So what is input? Input, as you know, there are two strings. So we would say string S is equals to anagram, let's say, and then string T is equals to, let me copy this other string. Yeah. And what is logic? So in logic, we are expecting answer. So let's say result. And this result is where we are expecting is anagram. So we are expecting here a Boolean value. So let me pass these two string S comma T. And then in the result, we just say is anagram, and then result. So that is pretty much all. On a very high level, my problem looks like we have input, we have logic, and then we will be talking about the final answer. So let's talk about in a similar fashion anagram, right? So anagram, as I already explained you the definition of anagram. So if a word or a phrase you formed by rearranging the letters of another using all the original letters exactly once. For example, this particular pattern here, you see S and T, these are two anagrams, so we're expecting true here output. But in case of rat and car, you see here RATCAR, so T is missing in this, so it means they are not anagram. So brute force approach, I think, directly comes in our mind. Just sort those two arrays and then comparing the sorted versions. So sorting the arrays could be any sorting algorithm that you can take. So I would say that would be the n log n if we are just taking the time complexity of any sorting algorithm, and then we can just compare those two arrays. So that is pretty much all when it comes to brute force solution. So time complexity would be O of n log n because we are using sorting. Of course, any optimized sort would always be n log n, and then space complexity will be whatever uh, arrays that we are using. So in case over here when we are sorting, let's say we are doing arrays dot sort, so it can consider having this um, array as an input. So we might need some sort of space where we can store this s and t in terms of array, right? Not the strings, because right now you see here this is string. So yeah, this is what we have here when it comes to brute force solution. But as I said, let's always go in for the more efficient solutions if we can do that. So the more efficient solution here would be, see, the problem is we have to understand frequency of each character. Okay, so to check the frequency of each character, so if two strings are anagram, that means all the characters of both the strings should exactly match in terms of its value and frequency. So why not take this advantage of this particular trick? So what we will do, we know that for example, let's say we know the fact that particular we have 26 letters in our alphabets. So we can create an array of which can hold characters count from A to Z. um, and then what we can do, we can count the characters in the first string. So for example, whatever characters we have in the first string, we can just count those characters and just initialize our character array. So what does it mean? Let's say we create a character array, an array to hold the characters. So let's say it's 26. So every time we found a particular character, we will be just updating that particular index for that particular array, so that we know that this particular character is found. And then when we can take the other string and then do the same but in reverse direction. So eventually what will happen, we are having one array which is like 26 of 26 character size, like index of each particular array element would be representing, kind of simulating the character value. So one string will be where we can just marking it on, and the other string will be marking it off. So adding and subtracting, and then eventually if my character array that was initially 26 has all non-zero, means if it is uninitialized, meaning it has been neutralized, like you have added something for particular character found in string s and then you have subtracted it. So that means you have zero value at that particular index. If that is the case, okay, it means all good. If that is not the case, it means we have these two strings are not anagrams, right? So I think this is the optimized and efficient approach. With this approach, we are just targeting here space complexity, also very fixed, which is O of 1. And when it comes to time complexity, as you know that we are iterating all those arrays till the number of characters. So it's, let's say if my string has n characters, so it will be O of n. The maximum of string s, the maximum length of string either s or t. So yeah, that is the optimized solution. So let's go and quickly code this. So you see here anagram, I have this method, so I need to create this method quickly. So I just create this method over here. And now, as I said, what I'll do, I quickly, there are some edge cases which I always would like to talk about. So s dot length, let's say if they are different lengths, it means we are good. We can just return t dot length. If these two lengths are not equal, what we can do, we can return false straight away. Yeah, I think this is pretty much straightforward. Always remember to have those edge cases in front, because these are the basic things which most of us sometimes overlook and do not write. So it's very important. So I'm just creating a count array which is integer 26. So I think this is a very common practice. Most of us have already done many times, creating an array with 26 size, representing the simulation of all the elements into the particular array. Remember, I created 26. You can create more size if you have some special characters or capital letters, and things like that. So it all depends. So this is a case where I'm considering that a small a to small z, okay, which is 26 in count. If these are the string values, then we are good. And of course you can optimize this, you can make it more better if you are targeting more characters. So yeah, this is my char array. So I'll just comment it, array to hold character counts for a to z, and then it's like count all char in string s and mark in count array. So I think this is pretty straightforward, right? So what I'll do, I just quickly go and say, hey, this is, where is this, my string s. So I just need to do char c and then s dot to char array. And what I'll do, this is very simple, count c minus a plus plus, okay, and we will do the same for the other part, which is like, just copy this unmark, okay, or you can say subtract or add, both are same. So there we will say minus minus, okay. So this is pretty straightforward. And then at the end, what we will do, we will have another for loop. Again, this will check return false if not 0, right? So over here, this is my count array, and I'll quickly check if, and over here what I'll do, I'm just doing int I and then count, okay. So what we will do, we will quickly check, this is my count array. So if this count array is like 26 items in this count array, so if any of the index, any of the element into the count array, so let's say item, so if my item is not equals to 0, okay, straight away return false. And if that is not the case, we will return, return true. And I think that should be pretty much all in terms of solution. Let me quickly run this and see if it matches. So is anagram true? Now we just do something like rat and then run it again. Is anagram false? That is also good. Let's make the same car on rat and run it again, and this is all good. So the time complexity of this, let's discuss time complexity. Time complexity of the time complexity over here. So now, as you know, that we already talked about the brute force solution, but this is the optimized version. So time complexity over here, you see, if we have an two string s and t, which are like n1 and n2 size in terms of total number of characters, And what we are doing, we are just iterating to all the till the length of the character. So it will always be O of n, and space complexity would be O of 1. Why? Since we are using only fixed size 26, I mean, if there is a constant k size space, so we can always consider that in terms of complexity, space complexity, as 1, O of 1. So that is pretty much all in terms of the solution. So let me quickly copy. Guys, do not remember, as I always highlight, whenever you are asked any particular problem to solve, always go with brute force, understand the problem, and then mutually, eventually then move towards the more optimized version of the solution. And whenever it comes to brute force, do not code that. Just say and talk about the time and space complexity and jump straight away into the code which is dealing with the optimized solution. So we already discussed here, this problem could have been sorted out by just sorting these two arrays and then comparing the characters into the array. So but that was more in terms of time complexity. It was O of n log n, which was a big thing. And over here now we optimize this to O of n. I just need to copy this part and copy. I just paste it here. Okay, so for some reason when I'm running this problem, it says it's failing. Yes, that's right. Let me check quickly what's wrong. So this is S. Yeah, so we got it. This should be T because we were doing the same. And now run this problem again. Okay, so this is passed. Now we submit the solution. Okay, so the problem solution is accepted. All good. Thank you guys, and we will see in other video.